refraction of the wave, the property of a wave to travel from one medium to another by changing the speed, we call that as refraction. So if a wave is traveling from a shallow region to a deep region, so we produce a wave. We vibrate an object, produce a wave. So what we will observe, if it's traveling from shallow to deep, so moving from shallow region to deep region, we'll observe that the wavelength increases, the speed increase, but the frequency remain unchanged. And the same reason, because frequency is actually a ratio between the speed and the wavelength. Just a minute. So as the wave is traveling from a shallow region to deep region, when we produce a vibration, so what we observe moving from shallow to deep, the wavelength and the speed increase, but the frequency remain constant, does not change. Because you have the formula V divided by lambda is equals to F. So V is the speed. Say speed was 2, the wavelength was 1, so 2 divided by 1, frequency was 2 hertz. Moving from deep to shallow, the speed increases, the wavelength also increase, but the ratio between them does not change. So as the ratio between them does not change, so example speed is 20 and the wavelength is 10, then the ratio will be 2, so frequency remain unchanged. So moving from shallow to deep, the wavelength and speed increases, frequency remain constant. This is when you're looking from the sideways, like you're looking this ripple tank from the sideway. But if you look from the top, what you will observe, like this is a ripple tank and it is having two regions. So I'm representing a two regions by different shades. So you can identify, like example, one shade is representing a deep region and the other shade is representing a shallow region. So if the wavefronts, these are the wavefronts, and these wavefronts are moving from deep region to shallow region. So the moment these wavefronts enter a shallow region, the waves slow down, so wavefronts and the wavelength decrease. So what we'll observe that the wavefronts come closer to each other. So as the wave travel from deep region to shallow region, the wavelength decrease, the speed decrease, but the frequency remain unchanged. But if part of the wave is in a deep region and some part is in a shallow region, then what we will observe, like there's a boundary, this line is representing a boundary between deep and shallow. Refraction happens when there's a change in density. Density can increase for a medium, it can decrease. So whenever there's a change in density of the medium, then refraction occur. So what we observe, example, some part of the wavefront is in a deep region and some part is in a shallow region. So the part of the wave which is in a shallow region will travel slower as compared to part of the wave in a deep region. So what we will observe, we'll observe the part of the wave which is in a shallow region will travel slower or lag. Because in a deep region it is traveling fast, in a shallow region it is traveling slow. So both regions there's a difference in the speed. As there's a different speed, so deep region the wavefronts are ahead, and shallow region the part of the wavefront which is in a shallow region will lag behind. So we'll observe a bent wavefronts. In a deep it is ahead, and a shallow it will lag behind. Is it clear? I'll show the patterns now. So example, this is a ripple tank and you're looking from the top. So these are the wavefronts which are incident. But you can see the moment the wavefront enter a shallow region, it slow down. And you can see the wavelength decreases, the speed also decrease, but the frequency, the number of vibration per second does not change. Is it clear? This is when you're looking from the top. And if you have, so when the wavefronts move from deep region to shallow region, they slow down. The wavelength shorter, but frequency remain unchanged. Now, if wave are making certain angle, you can see the wave is making certain angle and it incident. So the part of the wave which is in a shallow region, it slow down and it also bend. The wavelength decrease and the wave changes its direction when it is making certain angle. If it is not making certain angle, as the wave fronts are passing perpendicular or 90 degree to the surface, they will only slow down, wavelength decrease, frequency remain unchanged, but they will not change the direction. Why the direction change? Because the speed changes and the wave takes the shortest part. That's why the direction changes. When moving from deep region, deep water to shallow, so the wave fronts in a deep are moving faster, but the part of wavefront in a shallow moving slower. Because of this slow movement, they changes the direction. And this property of the wave to travel from one medium to another by changing the speed or the wavelength, we call that as refraction. Is it clear, the refraction of the wave? Any doubt in this part?
Sir, I
Yes.
have a question.
Yes.
Sir, I just don't understand why shallow water is denser than deep water.
Why shallow water is denser than a deep water? Because for a particles, small space is available. When you check the liquid, look, a container which is filled with water. So the particles, this is how the distribution of the particle occur. Okay. This is we call a uniform density. Uniform density means that the particles are evenly distributed. But if I place an object inside, a heavy object which can sink, I did not change, the total volume remains same. Volume does not change. But if I place an object inside, So what happened, as this object will take the volume, so the particles which are present for the water, these particles will come closer to each other relatively. So as the region where the particles are relatively closer, we call that region as high density. And the region where the particles, because they have more spaces available for them, still the distribution is not changed. That's why relatively it is having a low density. Is it clear? Like you, it's it's a change very small, like there is a change but small change. But if there is a greater difference in a deep and shallow densities, like depths, then there will be a greater change in the density. Yes, Mohsen.
Yes, sir, but like, won't the mass will be proportional to the volume? Like, we decrease the mass, we decrease the volume, but we also decrease the mass. So I think it should be constant, or there will be a slight variation.
Very slight variation is there, because what happened, the particle, yes, the particle, that, because what happened when you place an object inside, it's a very slight variation in the distribution of the particle. Because what happened, look, this is a uniform distribution, but when I place an object, so level of the water will increase. That's according to how much, what is the volume of the object which we add. So level of the water will increase. As this level of the water increase, the particles in a in a shallow region, relatively, because they have small space available to move around as compared to particles in a deep region. So in comparison, this is a comparison and it's a relatively small variation. It's like very small variation in the, but because the term refraction means the property of the wave to change speed when it travel from one medium to another. So how we can create a medium in the water? So to create a medium in the water, we use a deep and the shallow region.
Yes, sir, got it. Thanks.
Now some questions. There is another property, diffraction, that we'll discuss tomorrow, because I told you it will be a short class, so I just want to go through the refraction part. Question 5, the diagram represent a plane wavefront about to strike a solid barrier. Which diagram shows the position of the wavefront after reflection? A, B, C, or D? Yeah, it's C, because what happened? The wave which strike that incident, you will draw the normal imaginary line. That's normal, and the wave which bounce back, that is called reflected. So that's why C is the right answer. A plane wavefront in a shallow and part of the wavefront in a deep. In a deep, it will move faster. What could be the answer? A, B, C, or D? Because in a deep region, the wavefronts travel faster. So they will be ahead. So this will be the position and the wavelength will be higher. So C is the correct answer. Question 13, what could be the answer? The diagram shows a plane wavefront reflected by a plane surface. which represent wavefront. A is the direction of the wave, B is a wavelength, C is a wavefront, D is a reflecting surface. You can see A is representing a direction in which the wave is traveling. B is representing a wavelength. C is representing the reflecting, C is representing the wavefront, reflected wavefront, and D is representing the reflecting surface. So C is the correct answer for this. Question 16. What could be the answer? Which diagram represent the water waves in the tank? Which diagram changes the speed? So in case of D, the water waves are changing the speed. Structure questions. Figure 6.2 shows the water waves crossing the boundary from shallow to deep. The original wave direction and a new direction is given. Name the process that take place at the boundary between a shallow water and a deep water. It's a refraction, that's right. Tick one box correspond to the property of a wave that is same. Use the screen annotation to tick the box. You can mention the answer in a chat as well. Yes, the frequency. Yeah, that's right. Okay, in this question, question number 5B. Figure 5.1 shows 6 wavefronts traveling on a surface of a deep water. The wave is incident on the boundary where the water is shallow. On a figure, draw the wavefront in a shallow. So in a shallow, because it will move slower, so it will be lagging or lag behind. So how you draw these wavefronts? Using a ruler or a scale, you will draw the wavefronts. But all the wavefront which you draw should be parallel to each other. It means these lines should be parallel to each other. The depth of a shallow water is now changed so that the speed of the wave in a shallow is 0.6 meter per second. The speed of the wave in a deep region is 0.8. The distance between the successive wavefront is 1.4. Calculate the wavelength in a shallow region. So as we know, the frequency in the deep region and frequency in the shallow region will be same. Frequency in a deep is equals to frequency in a shallow. So frequency is speed divided by wavelength, also speed divided by wavelength. What is the speed in a deep region? The speed in a deep region is 0.8. So 0.8. The wavelength in a deep region is given 1.4. 1.4 centimeter, because if speed is given in meter, this should be also in meter. So I will divide by 100, so 0.014. Then speed in a shallow region, 0.6, and wavelength, we don't know. Just cross multiply, because reason is the frequency in a shallow and a frequency in a deep region are same. So speed in a deep divided by wavelength in a deep is equals to speed in a shallow divided by wavelength in a shallow region. Just cross multiply. So wavelength is equals to 0.6 multiplied by 0.014 divided by 0.8. What's the answer? 0.01, 0.0105 or 0.015? 105, okay. So 0.0105 meter. Is it clear, this question? Any doubt in this part?